core concept for section 3 of chapter 2 is using Venn diagrams to show whether or not claims are equivalent or contradictory. Of course, it could be neither. Plenty of claims are just different. I have an example of each. Let me also note here in the background that although the terminology is of significant background interest, terms from Aristotle's logic, especially like contrary, subcontrary, subalternate, as well as the other terms mentioned there, contrary, obverse, contraposit. That could be helpful for you to learn. I'm not going to expect you to have memorized that, and the reason being, if you know how to do Venn diagrams, you can glean all the relevant information in terms of how claims relate to one another. So let's take a look at set 1 over here to the right. Right here. Okay, I happen to have used green last. Probably pretty obvious here, some A or C, some C or A. If you've been doing well with the Venn diagrams, these two claims are equivalent. But we can show this by Venn diagrams by simply diagramming the first and then the second. Some A or C, because I have something that's A, it's in the red circle. It's also in the C circle, the green circle. That leaves us with areas 5 and 6. We're saying we have something either in area 5 or 6. That's the diagram here for the first claim. Some C or A, maybe we talk it out a little bit differently. We first look in the C's, 5, 6, 7, and 8. We're saying we have something that's in that circle, also in the A circle. That gives us the exact same marking. Wind up with the same diagram here, and so we can say that these two claims are equivalent. Alright, let's take that away and take a look at set 2. Think about how to diagram those two claims there. First we have all C are B. As we've learned, and let me emphasize one more time, focus your attention on the C's in all these cases in case you're having issues or getting confused. In this case it helps you avoid diagramming all B or C, for example. All C or B makes a claim about those things in the C circle, the green circle, and says all of those are B. So we can't have any in area 5 or 8 outside of the B circle. 5 and 8 again are exactly what we can't have if all C are B. So that's how our first claim would look. Now, some C are not B. And in the book I do these on two separate diagrams. You could put them on the same diagram or on two separate diagrams. It's a little easier to see on separate diagrams, but I'm doing them here together on the same one. We're trying to diagram the second claim, some C are not B. Diagram some C are not B makes a mark between 5 and 8. So you can see how I'm fighting myself here. I've said two opposite things. I've said in the first case I have something that's in the first case that I have nothing that is C and not B, nothing in areas 5 and 8, and the second case says the exact opposite. Yes, I do have something that is C and not B, and probably it's also clear at face by looking at these two claims, and you also want to keep in mind this kind of intuitive thing that these claims in fact are, just abbreviating again, contradictory. Okay, so once again, I'll say while I'm erasing this that if the diagram is the same for the two claims, that shows in this pictorial kind of way that Venn diagrams show things, that two things are the same or equivalent. By the way, you know, it is important to know when claims are equivalent in a big picture kind of sense, a philosophical sense. People are discussing things. You want to know when exactly they do and don't agree. So the concept of equivalency is very important. By the same token, you want to know exactly when to people or passages, texts are disagreeing and precisely about what, and that's how the idea of contradictoriness has a significance in language and thought. Alright, I just wanted to show one of the other kinds, and that's a pair of claims that are neither equivalent nor contradictory, what that would mean is they're just different. They don't have the exact same diagram or the exact opposite diagram. That's going to occur here. I also have a little bit different kind of claim for the first one, no non-A or B. Extra negation in there makes things a little bit more complicated, like some of the later problems and exercises both in this section and in the last section. No non-A or B. The way we diagram that is to shade out the non-A that are B. Got to remember that negation, the non-A, so we're outside of the A circle, outside of the red circle. You don't have any non-A that are B. You got to shade out the non-A's, things outside of the red circle that are in the blue circle. It's areas 4 and 7. Take a look at that. Go back in the video, pause it, and so on and so forth if you need to. That's our first claim. Second claim says all A or B, one of our core claims, but you still have to think about it, and all is the trickiest kind of claim. All A or B, though, the way we diagram that is shade out different areas on the diagram, areas 2 and 5, and what we've just shown is that these two claims say different things. They put different things on a diagram, and so they are neither equivalent nor contradictory.